All right, so in this video, we're gonna return to the elimination method. So based on our skill check, you had a couple learning objective skills. You can do the elimination method when it's set up for you. And now basically in this video, we're gonna learn how to set up the elimination method if it's not already there for you. All right, so that's basically what this says. All right, sometimes you can't immediately do the elimination method or the substitution method. So you need to kind of change your system in a way that sets it up for one of those two things to happen. All right, so we look at this system. We definitely can't do the substitution method because there's no y equals or x equals in our equation. And we can't do the elimination method because we add these, we get 8x minus y equals 8. And there's still two variables, so that didn't eliminate anything. All right, the idea of the elimination method, though, is to get things to be opposites of each other so that when you do add them together, they go away. All right, and you can do this for either of the variables, either x or y, but sometimes one is going to be less steps than the other. For instance, if I try to get the 3 and the 5 to cancel out, there's a bit of work to do there. But if I want to get a -2 to cancel out with something down here, what I can do is just take this entire second equation and multiply it by 2. All right, so let's see what that's going to do to my system. I didn't change the top equation at all. So I'm just going to recopy that. But I'm going to multiply everything in the bottom equation by 2. And as long as I'm multiplying everything by the same number, it doesn't actually change the equation. It just makes it look different. So 5 times 2 is 10x plus 2y equals 10. All right, now we have exactly what we want in the elimination method. If we kind of stack these on top of each other, -2y and +2y are going to cancel. So when I do my elimination method of adding the sides together, I get 13x equals 13, and divide to get x equals 1. So the only extra step you have to do now is figure out how can you manipulate, how can you multiply your original equations to make the elimination method actually cancel something out. And again, as I've said a lot for the system stuff, we need an order pair for our answer, so we're not done yet. We can plug this x equals 1 into any of these equations. You can plug it into this first one, the second one, the third one, or this fourth one, because all of those are part of the system. All right, the original ones were given to us, so those are definitely part of the system. The second set are just ones we slightly changed, those are also still the original system, just with different numbers. Generally, what I would do is plug it into the one of the original two, because chances are, since you haven't multiplied, the numbers are going to be smaller, and smaller numbers is always a good thing. All right, I'm just going to go ahead and plug it into the second one. And the reason I'm choosing the second one is because there's nothing else going on with the y. Oh, except for I'm plugging in for x. Still going to choose the second one. Plugging in 1 for x. Subtracting the 5 to get the y by itself. I get y equals 0. So it looks like my final answer should be 1, 0. And let's see, 3 equals 3, 5 equals 5. Yep, so that's good. This is my final answer. All right, so in this kind of learning objective, you just have to figure out how can you manipulate the equation to make it so that you can use one of the methods we learned before. All right, so here's your turn. Go ahead and try to solve the system, figure out how you can manipulate these equations to make the elimination method actually work. All right, there's multiple ways to do it. When I put up my solution, those will be the way that I saw it first, but just know there is multiple ways, but just figure out how you can make this work to eliminate one of the variables. And here's the answer I got. The numbers tend to not work out very well. All right, so the main thing I want to make sure that you have is this first step of how can I get one of the variables to cancel. I think because you see one's positive and one negative, it's easier to start with the y, so I'm just going to make those numbers be opposite of each other. I do that by multiplying the entire second equation by 3. All right, so I get 2 times 3 is 6, 1 times 3 is 3, 5 times 3 is 15, and then you can see these y's go away and I get an equation with just x. From there, x up being this fraction that I plug in. Again, you can plug it into any of the equations. I chose this one. I had 2x minus y equals 5 because there's less numbers. There's no number in front of the y, so it's a little bit simpler. All right, when I do that, plug in x, multiply, move this to the other side, and solve for y, I end up getting your final answer, 19 over 9 and -7 over 9. All right, so that's the solution to this system. But again, when you're trying to use the elimination method, the main thing is that first step of making the numbers match up so they cancel. All right, in this case, it's not as obvious if I should cancel out x's or y's, because not one isn't positive and one's not negative. So really it's up to you how you want to go about this one. There's like 8 different options of how you could go about it. It seems like we're canceling out x or y's a lot, so let's cancel out x's. So I want to cancel out these x's, which means I need to make them the same number and one be negative. All right, so you're asking yourself, how can I change a 2 and a 4 to be a same number? This is very similar if you were adding 1/2 plus 1/4. Getting a common denominator, getting these numbers to be the same is pretty much the exact same thing we're doing here. And I think the least amount of steps this is going to take is taking that top equation and multiplying it by -2. All right, so that's going to give me -2x minus 10y equals -2, and not -2x. I already made a mistake because I'm multiplying by 2, -4x. And my second equation, it didn't change at all. Then I can add these equations now that the elimination method will actually work. It's going to be -7y equals 0, which means y has to be 0. And again, once you have half the answer, now I know what y is, I need to figure out what x is. You can choose any of the equations. Generally, you want to choose the original ones just because the numbers are going to be smaller. So I'm going to choose the original top one. All right, so plugging in y is 0. And then dividing by 2 to get x has to be 1/2. So my final answer should be 1/2, 0. And looking at it quickly, that satisfies the second equation as well. So this is the solution to our system. All right, so this is one way to do this problem. I'll show the first step of just a slightly different way you could do it. So let me just erase everything. And again, if I'm erasing and you haven't finished writing it down, just pause the video and you can finish copying it down. All right, so let's say in this problem, I want to get rid of the y's in front of instead of the x's. So if I want to get rid of the y's, I need to get basically a common denominator between 3 and 5, get 3 and 5 to match up. And what you can always do, just like we did with fractions, I can take this top equation, multiply by 3, because that's that number. Take the bottom equation, multiply by 5, because that's the top number. And that'll guarantee that the numbers in front of the y match up. The only other thing you have to do is make sure one of them's negative, so just pick at random. I'll pick that one because there's a little bit more room in front of it. I'll pick the 3 to be negative. That's now my new system is going to be -6x minus 15y equals -3. Again, make sure you multiply everything by that number. 20x plus 15y equals 10. And then we'll get, let's see, the y's are going to cancel now when I add. I'm going to get 14x equals 7 divided by 14 to get 1/2. Right, and you could solve the rest of it to get the y as well. But I was just showing you another way you can use the elimination method. Right, so on this one, go ahead and try this one on your own. It looks like for this one, you're also going to have to multiply both equations like I just did. All right, but figure out how you can get the elimination method to work. And here's the way I did it, and just give you a little insight of why for this problem, I'm getting rid of the y's instead of the x's. The reason is because these signs are already different. One's already positive and one is already negative. All right, so I don't have to add an extra negative sign there or anything. All right, so that's the reason I'm getting rid of y's instead of x's, but there's nothing wrong with doing the x's. You would have done something like multiply the top equation by 3, the bottom equation by -4. That would get rid of the x's. And for this problem, I got rid of the y's. I've been multiplying, again, just by the opposite number. So I multiply by the 2 up there, the 3 down there, and that guarantees that these are opposites of each other and they cancel out. Get x equals 1, and then finish the problem by getting y equals -2. As again, make sure you look through that, kind of understand what I did, compare it to yours. You might have done it in a different way, but got the same answer, and that's perfectly fine. All right, but just look at that and kind of figure out, do you understand the elimination method when you have to do steps on your own? All right, so this learning is just going to be a bit different. So what we're going to do now is you're basically just going to go straight to the next video, as long as you understand this video. If you don't understand this video, ask some questions about it, figure out those examples I went through and the problems you had to work on your own. If you understand it, go directly onto the next video, which is going to be about the second part of substitution. And then after that, you'll start working on the practice. And the reason we're doing it that way is because I don't want to tell you to just do the elimination method or just do the substitution method. I want you to kind of figure out as you look at them which one you're more comfortable with, maybe which one works better for certain problems. All right, so you're going to do the practice for those two learning objectives together at once. All right, so again, after you understand this video, then go watch that next video, and then you'll do practice.